general overview, and then we'll talk about some specific glands, specific hormones, and we'll go from there. So first off, the endocrine system itself, it's a system of what we call ductless glands. And what that means is that a duct is sort of like a tube which things travel through. But the glands of the endocrine system, they don't send their hormones through tubes. They send them directly into the bloodstream. So that's why we say ductless glands. And they secrete, that means they produce or they make hormones, special chemicals that signal different things to happen inside of our bodies. So that's what the endocrine system is, a system of glands. It produces hormones which go into our bloodstream and have various effects on different parts of the body. You don't have this part, but to talk about the origin, we talk about the origin of words a lot. Does anyone remember what endo, the prefix endo, means?
Oh, wait, never mind. I was going to say
Endo. It was, we talked about it when we were talking about humans and vertebrates, because arthropods had an exoskeleton, vertebrates had an endoskeleton, means inside. The root cream means secretions, or things that are produced. So endocrine things are produced inside the body. And these hormones, the word hormone means to excite. And hormones are called that because as these hormones are released into our blood and travel to various parts of our body, they cause different things to start happening. They start an organ working, or they start some process that's going to be helpful to help regulate conditions within the body. And the levels of various hormones in the human body, they go up and down. They change. They change at different ages. They change at different times of the day, different times of the month or the year. And so these hormones are controlled by what we call a feedback system. And this feedback system turns the endocrine glands on or off as needed to help regulate things in our body. And so to understand what a feedback system is, it's helpful sometimes to think about like a thermostat. Because this is the way many of the endocrine glands work. Like this thermostat over here, and you guys know you have one in your house.
Yeah.
What is a thermostat's purpose?
It takes the temperature in the room, and if it gets too cold, it sends a signal to the furnace to start.
Yeah. The thermostat's job is to control the temperature of your house or this room. And so this thermostat right here, it's set at, let's say, 68 degrees. And so this thermostat is monitoring the temperature of the room. It's got a little thermometer in there. It's monitoring the temperature of this room. Okay? Now, if it monitors the temperature of the room and the temperature drops below 68, what does this thermostat then do, Michael? Yeah. Yeah, it sends a message. It sends a message to the heater in the back of the room telling it to turn on. So this tells the heater to turn on. Obviously, then the temperature in the room will rise. And what happens once the temperature rises to 68? Jaden?
It starts to kick on, or the heat starts to go off.
Yeah, it sends another message. When this realizes, okay, the temperature is back to what we need, sends another signal to the heater and turns it off. So this regulates the temperature of the room, but it doesn't do it by, no heat comes out of this thermostat, right? It does it by sending messages to another piece of equipment in the room, the heater, and that's what actually raises the temperature of the room. But it's the thermostat that controls whether the heat's on or off. So the thermostat's like an endocrine gland. Many endocrine glands monitor the conditions in the body of a certain thing. And when they realize it's not at the right level, they send a message to some other organ that makes an adjustment and gets things back at the proper level. That's a feedback system. It's monitoring and keeping conditions at the proper level. Logan?
Can you make it if it's like too hot, then it could like send messages to...
Only, now, it's a good question. So in our room, the only message the thermostat could send is one to the heater, and it tells it to turn off. But if we also had an air conditioner in the room, it could do that. It could say, okay, heat off, send a message to the air conditioner, tell that to turn on. And so as one piece of equipment that brings the temperature of the room up and another that brings it down. So some, like the pancreas, which we'll talk about today, can do that. It has certain hormones that tend to bring blood sugar down, and other hormones bring blood sugar up. So it can do both ways. Good question. So the purpose of this is to maintain what we call homeostasis. And homeostasis is keeping balanced conditions. You know, if we're talking about the temperature, it's keeping the proper body temperature. Or it could be keeping the proper amount of salt in our body fluid, or keeping the proper pH of our blood. So there's all sorts of different factors about our body that our endocrine system needs to control and regulate. So when you think about these endocrine glands, the way that they work, it's not too complicated. So they make these things we call hormones. A hormone is just a molecule. It's just a little chemical. They're pretty small. They're proteins. And different endocrine glands produce different hormones and send them into the blood. And then they circulate around throughout the whole body. You know, for example, some hormones only have an effect on our bones. But those hormones are all throughout our blood. They're going to your brain. They're going into your stomach and into your lungs. They don't do anything there. The only time they're actually working is when they get to cells in your bones. So they're made by the glands. They're sent into the bloodstream, and they're bringing a message. They're a signal. They tell something to happen. Okay? They excite a body activity. Maybe they tell your bones to start to grow. Okay? Maybe they tell your organs to take glucose out of the blood. They can do lots of different things to help control and regulate our body. So we'll talk specifically about a couple endocrine glands today, and we'll talk about more tomorrow. The first one is the pituitary gland. The pituitary gland is a very important gland. It's found actually in your brain. Your pituitary gland, this is the cross-section of the brain, and the pituitary gland is a tiny little gland at the base of your brain. It's often called the master gland. Because the pituitary gland produces a whole bunch of different hormones. It doesn't just produce one hormone, it produces several. And these hormones actually regulate other endocrine glands. So it's a gland that regulates glands. It's pretty small. It's just a little thing about the size of a pea in your brain, but very, very important. And it produces one important hormone that's especially important to you guys at the age that you are. And that's human growth hormone. So it produces, one of the hormones it produces is human growth hormone. And what human growth hormone does is it's produced in your pituitary gland up near your brain. It circulates throughout your body, in your blood. And when this growth hormone arrives at cells in your bones, it sends them a signal. It's telling them they should start to grow. They should elongate. And the cells start to divide and your bones get longer. Human growth hormone is why you grow at different stages of your life. So now probably many of you, your pituitary glands are very active in producing human growth hormone because you're growing. For me, my human growth hormone is much lower. As you reach your full size, the amount in your blood decreases and you stop growing. And your bones sort of solidify and you stop growing. And it's also why you go through growth spurts, where sometimes you may go 6 months and you might grow a couple inches in those 6 months. It's a time probably when your pituitary gland is very active, and then there may be other times when it slows down. So all these things are related to our growth. It's actually also, if you follow sports, you may know it's a banned substance in sports. And some athletes have gotten in trouble for giving themselves human growth hormone. I mean, they give it to themselves not to grow taller, but human growth hormone also helps in like the repair of injuries and muscle growth and things like that. So it's related to steroids and other performance-enhancing drugs that athletes sometimes use to artificially boost their performance.
Is it like dope? Like doping?
It's doping includes like anything you do to artificially improve your performance. So this is one form, yes. Also, there are some disorders of the pituitary gland that lead to various abnormalities. And one of them is dwarfism. So dwarfism is if a person's pituitary gland does not produce growth hormone from a young age, then they don't grow to a normal height. Their bones and their muscle are not getting the signals telling them to grow larger. And so a person with dwarfism is doesn't grow to a normal height. And at the opposite end, there's the opposite problem also can affect people, called gigantism. An overactive pituitary gland can produce too much human growth hormone, and that leads to a person growing to an abnormally tall height. Yeah, so we'll talk about it in a minute. But gigantism, an example, this is Robert Wadlow. He was the tallest, we're going to watch a video about him in a little bit, but he was the tallest person ever been documented to be alive. He had a tumor on his pituitary gland, and the effect that this tumor had is it caused his pituitary gland to just constantly produce growth hormone. It didn't go up and down throughout his childhood. It just stayed at a very elevated level, causing him to grow. He never stopped growing. He grew from the time he was born. He was at an abnormally tall height all throughout his whole childhood, his adulthood, until he passed away at the age of 22. When he was 5 years old, he was already 5'4".
What?
So he was over 6 feet tall when he was 8 or 9 years old. He continued to grow throughout his life. So that comes with a whole host of other problems, because if a person grows that tall, he had extremely large hands and feet. He had poor circulation in his feet. His ankles were not strong enough to support his height. He weighed over 400 pounds. His ankles were not strong enough to give good support to him. He had to wear ankle braces. He obviously, furniture and stuff, he had to have custom-made clothes, and his shoe was a size 40. He had to have custom-made shoes, and actually that's what led to his death is he had to wear braces, and one time one of his braces cut into him and caused an infection. Just caused like some blisters, like a small cut, but it got infected, and that infection eventually spread throughout his body and killed him at the age of 22. But up until that point, he still was continued to grow to age 22. He went on tour with like the circus, with the Ringling Brothers Circus. People would pay to see him and to have their picture taken with him. And you'll see in the video, he was sort of a normal. See, what was strange is that he was a normal kid, but he looked like a grown adult. So you'll see in the video some pictures of him in his class, and he's double the size of the other kids in his class, but he was still a kid. He still thought like a kid and wanted to play like a kid, and he was just a kid. He's just very, very large.
Was he smart?
He was like, I think, average intelligence. Michael?
Could you also be determined on your height by like your parents?
Yeah, so that's due to an abnormality, what we're just talking about. But the vast majority of people, your genetics, your genes, your DNA has a large impact on your height. So if your parents are both tall, chances are that you'll be relatively tall. If your parents are both short, chances are you would be. But there are other factors that are involved as well. There's your diet and other things like that. So it's not entirely a genetic basis. All right, a few questions, then we got to move on. Caleb? He was 8 feet 11 inches tall at the time that he died.
So he was.
I'll show you another picture in a minute. Grace? I don't know. That's a good question. He never stopped growing until he died. But the problem is eventually becoming so tall, your circulatory system can't work as well. It can't get blood up to your brain and throughout your body. It's not adapted to working under those conditions. So people that have that disease have usually lots of other health effects that go along with it. That means often they may not live to an old age. Jaden?
My dad's like 5'8", and my grandma was like,
You
when
got it.
they were married, my grandma was like 5'2", but my uncle's like 6'5".
Yeah, there's lots of times that children are taller than either parent. In fact, that's often the case at each generation. People get older, and part of that has to do with health and nutrition and things like that. All right, just some other pictures. Andre the Giant, if you know, he was like a 1980s like WWF wrestler. He was really tall. I don't know. He was over 7 feet tall. He had gigantism as well.
He was 7'2".
Young
man.
And tallest man on earth, right there. That's Robert Wadlow and his father. I think this was him around age 18. He was almost twice as tall as his father. I don't know. All right, and this is him compared to Mr. Arcuri's height. That's really Mr. Arcuri. Yeah, he's holding a ruler like a measuring stick. That's not a real. That's a model of him at like the Ripley's Believe It or Not Museum. That's really Mr. Arcuri.
Oh, is that a cool museum?
Yeah, they're kind of neat. No, it's real. All right. So last thing I'm going to talk about today is the pancreas. The pancreas is a very important endocrine organ in our body, and it produces an important hormone. Anyone know what it's called?
Insulin?
Yeah, insulin. So the pancreas produces a hormone called insulin. And why are you probably familiar with insulin as a hormone, Jackie? Yeah, because you probably maybe know somebody that has diabetic, a relative, a friend, and what that means is that a person with diabetes, their pancreas doesn't function properly, and their body does not produce insulin, or their body doesn't respond to it in some cases. And that's a problem because insulin has an important job in our body, and its job is to regulate our blood sugar, our blood glucose level. And it is important that we have the proper amount of glucose in our blood. You know that glucose is what our cells use to get energy. So we need a certain amount in our blood. But too much glucose, an excess of glucose in the blood, can also be damaging. It can damage nerves. It can damage your eyes, your eyesight, and things like that. So it's important that we maintain the proper blood sugar level, and our pancreas help us to do that. The way, let me explain, then I'll get back. The way that it does this is through a feedback system. So right now, for example, you guys just were at lunch. You ate one of those ice cream cookie sandwich things. Yeah. Right now, as you are digesting that, what is there a lot of in those? Sugar. A lot of sugar. So right now, going into your bloodstream as you digest that is a rush of glucose going into your blood. And if your body didn't take care of that, that could be dangerous. But what's happening is right now your pancreas is monitoring the amount of glucose in your blood. And it starts to realize that the blood sugar level is getting too high. And so what it does is basically the pancreas turns on and starts to make insulin. So just because we're going to fill in each gap. So the pancreas, this is at the top. The pancreas turns on. Just draw the arrow there. At the top. Right at the top is the pancreas turns on. We're going to go in a circle. And it starts to make insulin. It sends this insulin into your blood. And so it will be circulating all throughout your body. And what insulin does is it sends a signal to your liver and other parts of your body saying, look, there's too much glucose in the blood. Take some in and get it out of the blood. And so your liver and other parts take in a bunch of that glucose. And therefore, your blood sugar level comes back down. And again, your pancreas is monitoring this. And when it realizes that your blood sugar level is back at a normal level, what do you think it does? Yeah, it turns off. It says, okay, we're good. It turns off. It stops producing that insulin. Until when? Yeah, until the next time you have another meal, you have another rush of sugar into your blood, and then the process can start over again. So your pancreas is constantly monitoring your blood sugar and sending insulin into your blood to keep it at the proper level. If a person has diabetes, they may not be producing any insulin. And they may have to give themselves an injection of insulin regularly. Or they may have an insulin pump that gives them insulin into their body in an infusion site. Or there's an insulin inhaler. There's various ways of getting insulin into your body. But they are, because the pancreas isn't doing it. And you know somebody that's diabetic, you know they have to monitor their own blood sugar. They may have to test themselves to see what their blood sugar is so they know how much insulin they need. All right, any questions up to that point?
No.
We're done.